Hello everyone, today we're going to do Unit 7 of the Algebra 1 and Algebra 1 Honors Summer Packet, and today we're going to focus on the laws of exponents. So let's go ahead and get started. The very first thing we want to do is do a quick review, okay? There are lots of different pieces that make up this whole problem, and it's important that we know what they're called. So all together, this is called a power, okay? But there's different components that make up that power. The first one is the variable. The variable right here, or better known as the base, which is what is getting multiplied multiple times. Okay? The base can be a variable or it could be a number. The next really important thing is this little number in the corner, and it's always going to be like up high. This is called the exponent. This number tells us how many times we're multiplying the base by itself. Finally, this is a coefficient. If you don't see a coefficient there, that's okay. It really is an invisible one. But the coefficient is basically what you're multiplying the result of this exponent base with. Okay? So there are 7 laws total, and we'll be talking about all of them. You don't need to know the names per se. The big important thing is that you understand what to do when you see something that looks like it. Okay? So the first law is called the product of powers. What this is, it means that you're multiplying 2 different powers together. What's special about it is that if they have the same base, like these guys have, then that means you can add the exponents together. So if you're multiplying and they have the same base, you would add the exponents. So here's an example. We have x to the 4th times x to the 5th. Same base being multiplied together. You can add the 4 and the 5, and that's your new exponent. So you get x to the 9th. The next law is called the power of a product, which means you are multiplying something on the inside, and the product, the result of that multiplication, is being raised to an exponent. So the base is your product. What you would do in this situation is you would actually apply that exponent on the outside to every part that's getting multiplied together on the inside. So m would go to the a and to the b. So we would actually distribute that exponent. Here's an example. So we have x times y to the 3rd. We're going to change it so it's x to the 3rd times y to the 3rd. They both get the exponent. Another example would be 4s squared. The squared would go to the 4 and to the s. So we'd have 4 squared times s squared, and we wouldn't normally leave it like this because we know how to do 4 squared. We can easily put it in a calculator, or we have memorized it and we can replace it with the 16 and then write 16s squared. The next law is the quotient of powers. So that means 2 powers are being divided. So when you have division and you have the same base of those powers, it means you can subtract the exponents. Okay? Here's an example. We have 2 to the 7th divided by 2 to the 6th, so same base, and we're dividing. We can subtract 7 minus 6 gives us 1 for the exponent. And then we can simplify that 2 to the 1st, it's just 2. Another example is g to the 11th over g to the 4th. We have a quotient, we have same bases, so we can do 11 minus 4 and create our new exponent of just 7. Law 4 is the power of a quotient. So we have things being divided inside parentheses and we have the exponent on the outside. Very similar to a power of a product, we are going to distribute that exponent to everything inside. So the base, what's actually being raised to the exponent, is a quotient. We would go ahead and distribute the exponent to the top and bottom. Here's an example. 3 over k, we've got the division. We have the exponent on the outside, so we're going to distribute that 4 to both the top and the bottom. So we get 3 to the 4th over k to the 4th. And we're not going to leave it like this because we know what 3 to the 4th is, or we can at least easily find it, and we're going to write it with the 81 instead. So 81 over k to the 4th. Law 5 is a power of a power, meaning you have a power inside parentheses, all being raised to an exponent. So what's happening here, so you got your power on the inside, and it's creating a power for the outside as well. what really is happening is that you have one base but two exponents. So when that happens, you actually multiply the exponents together. You keep the same base but multiply the exponents. So an example would be b to the 4th to the 5th, one base, two exponents, multiply those numbers together. So 4 plus 5 gives you b to the 20th. Law 6 is negative exponents. So negative exponents are a little tricky just because they're something that happen a lot. You'll see negative exponents happen a lot, but you don't really see them very often in answers because people deal with those negative exponents. We don't like negative exponents, we only want to have positive ones. So when you see a negative exponent, what it actually is telling you is that I'm not in the right place, put me in the right place and I'll become positive. So, for example, we have x to the negative n. That negative sign has nothing to do with the number or being negative. It just says, hey, I'm in the wrong place. So when you see a negative in the top in a numerator, or just by itself, what it actually means is that this whole power should be in the denominator. So you would move it down below the fraction line, just the only thing that has a negative exponent though, and once you move it to the correct location, it turns into a positive. Okay? So that negative is really just your big flashing warning sight saying, hey, I'm not supposed to be here. Okay? Same thing happens if it's negative on the bottom. It's warning you, it's saying, hey, I'm not supposed to be here. So if it's not supposed to be on the bottom, it should be on the top. And when you move it to the correct location, it becomes positive. Okay, here's an example. We have y to the negative 3. It's telling you I'm in the wrong location. Please move me. And I would move that to the bottom of a fraction. So if I don't have a number, if I don't already have a fraction, I would just put it under 1. And then once I move it to the bottom, it's in the correct location, so I change it to be positive. Here we have 3 over t to the negative 2. The t is in the wrong location, so we need to move the t to the correct location to be on top. The 3 is already positive, so we're not moving the 3 at all. So we're going to move the t up there with the 3, so it becomes 3t squared. And our last law is the zero exponent law, which basically just says if you got a 0 as an exponent, the whole power just becomes 1. Just get rid of the whole base and exponent and just put a 1 there. That's all it is. Here we have 3 to the 0, so that just equals 1. Here's another example. We have 3b to the 0. Now b is the only thing that has the 0 exponent. 3 is not part of it. So we would just go ahead and change the b to the 0 into a 1, keep the 3, and then we can just multiply. 3 times 1 is just 3. Your try on your own are to name the exponent rules that are being displayed here, and then to apply those rules to simplify your answer. Okay? One little hiccup you might find is that you should only have positive exponents. So if you get a negative exponent, you're going to have to move it to be in the correct location. But go ahead and give those a try, and we'll make sure we go over them in class as well. And that's it. Thanks, guys. I'll see you next time.